Geometric series notes. A geometric series is the expression for the sum of the terms for a geometric sequence, which we've already talked about. So the sum as of n of a finite arithmetic series is where you're adding up all those terms together, where your r value cannot be equal to 1. That's, remember, your common ratio. So a sub 1 is your first term, r is the common ratio, and n is the number of terms that you have that you are trying to add together. So for this first example, it says use the finite geometric series formula to evaluate the series. So if we look at this, you can see that there's 1, 2, 3, 4, 5, 6 terms. That means n equals 6. My first term, we can see from just looking at the equation, is 3. And my common ratio, we know we divide the two terms, so 6 divided by 3 is equal to 2. And now I can go ahead and put it into my formula. So the sum of the 6 terms is equal to, and in this case we have 3, and that's times 1 minus 2 to the power of 6, all divided by 1 minus 2. So if you were to do this in your head or use your calculator, you get 189. Now, of course, something that's short like this, it's easy just to actually add up all these values. But of course, this is going to be more helpful for when we have a larger series that we have to add together. And we don't want to have to add each, like if we had 100 terms, we wouldn't want to have to add all those up together. Another way you can find the value of what this is equal to is using your summation notation like we talked about for arithmetic series. So let's go ahead and take a look at that. So if I used explicit formula, which we've already learned, we know that my nth term is equal to, for geometric, my first term times my common ratio to the n minus 1 power, and that's of course for n values greater than or equal to 1. And so for this, we can write this using summation notation. So the sum of the term starting with the first term to the sixth term for 3 times 2 to the n minus 1 power is another way we can find this, and then we could use our calculator. So in my calculator, if you go to math and you scroll all the way down, some of you may have this and some of you may not, depends on how new your calculator is, but we have that summation notation. So if you do have it, you can go ahead and hit enter. And for this, we're going to use x for our variable because it's just easiest. So x is equal to the first term, and then if you hit the up arrow to the sixth term. And for the summation notation, you always need to use the explicit form. You cannot use the other form that we have. So for this, we have 3 times 2 to the power of x minus 1. And now I can go ahead and hit enter, and we see we also get 189. Now, if you don't have this summation notation in your calculator, we've talked about this before, but you can use another way of doing this would be to go to second stat, and if you go to the last part which says math, you can go down to number 5, which is the sum, and second stat options of the sequence, which is number 5. And so another way to write this would be writing in the expression. So the expression, it's always using your explicit form. So 3 times 2 to the x minus 1. And I need to put that in parentheses. Okay. And the variable, of course, we're using is x. So the starting term is 1. The ending term is 6. And it's going to paste that in for us. If you have an even older calculator, you'd have to write this yourself. So you always write the expression, the comma, which is above the 7, the variable, comma, start term, comma, end term. And then I can hit enter, and it also gives me 189. So just different ways of doing that. Also notice if I go back to this and if I take out the sum, if I just do the sequence of all that and hit enter, Notice that it will write out the terms of the sequence for you, which is kind of nice if you need to do that. So that's just something else to take a look at. And so if we go back here, this was also 189, so just kind of checked our work. So looking at the next one, we can do the same thing. So you could pause the video and do this on your own and then unpause it to check your work. So in this case, we have n is equal to 4, because that's 4 terms. A sub 1, which is our first term, is 1/3. Then we have our common ratio, which is 1/9 divided by 1/3, which is also 1/3. So for this, the sum of the 4 terms is equal to 1/3 times 1 minus our common ratio, which is 1/3 to the 4th power, and that's divided by 1 minus 1/3. And if you plug this into your calculator, I would make sure to hit the math fraction key. And notice if I plug this in my calculator, notice I'm using parentheses around the 1/3. So that'd be 1/3 to the power of 4, and then close that parentheses for everything in my numerator, divided by, and always put your denominator in parentheses as well. So 1 minus, and then parentheses 1 divided by 3. And if I hit enter, I get a decimal, so I can go ahead and hit that math fraction key, and I get 40/81. Now for this, you could also, of course, do the explicit form as well. So if I did the explicit form, I would get a sub n is equal to the first term times the common ratio to the n minus 1 power. And that's, of course, for n values greater than or equal to 1. So this would be the sum of the first term to the fourth term of 1/3 times 1/3 to the n minus 1. And if we plug that summation notation that we learned underneath the math in our calculator, we would also get 40/81. So that would basically check our answer. So let's ahead and look at example number 2. In March, the Thorne family starts saving for a vacation in August. The Thornes expect the vacation to cost $1,375. They start with $125. Each month they plan to deposit 20% more than the previous month. Will they have enough money for their trip? So go ahead and pause the video and see if you can do this on your own first. So looking at this, you would want to identify each of your terms. So a sub 1 is equal to, of course, 125, because that's what it tells you they start with. Then you have to figure out for this what your common ratio is. So if each month you plan on depositing 20% more, and so that means that your R, remember, is 1 plus the rate. So this would be 1 plus 0.20, so 1.2. Because remember, 20% as a decimal is 0.2. And then your number of terms, you have to figure out for this, if we are going from March to August, that would be an n value of 6 months. So for this, the sum of the 6 months would be equal to 125 times 1 minus 1.2 oops, 1.2 is to the 6th, not the whole expression, divided by 1 minus 1.2. And if you were, of course, to plug that into your calculator, you would end up with $1,241.24. So unfortunately, we would say Miss Thorne doesn't have enough money for the trip. So unfortunately, she cannot go. All right, so let's look at the next part. Evaluating an infinite geometric series. So in some cases, you can evaluate an infinite geometric series, and that's only when your absolute value of R, your common ratio, is less than 1. We say that the series converges and gets closer and closer to a sum, so that means we have a sum. And when the R value, the absolute value, is bigger than or equal to 1, we say the series diverges or has no sum, so it does not approach a sum. Or we could say it approaches, and that should say no limit. So there is no limit. Converges means it does have a sum. And so if you kind of think about why that is, think about what, something that's exponential looks like. So if we have a graph that's continuing to go up, it's not going to be reaching any value because it's going to be going to infinity. So remember, infinity is not really a number, so that's why we say there's no limit. And if it is something that's the common ratio is coming down, that's going to be converging to some value or some limit that you have because you can figure out what the limit is for that. So let's go ahead and look at these examples. It says decide whether each infinite geometric series diverges or converges and state whether it has a sum. So for this one, we need to figure out what our common ratio is in order to figure that out. So negative 1/3 divided by 1 means we have a common ratio of negative 1/3. So remember the absolute value of R in this case is less than 1, which means it does converge and it has a sum. If we look at this one over here, this is just a little bit a different way of writing this. So as you notice, this right here is our explicit form for our geometric sequence. So that's 5 is my first term, and this is my common ratio. So in this case, R is equal to 2. And for this, then the absolute value of R is greater than or equal to 1. So that means this diverges and has no sum. And how do I know that's what it wanted me to find? So for this one, notice that it has 3 dots in the ends. That means we're trying to add up the entire series. And for this one, it had the infinity up here. So from the first term and on and on and on and on. So that's how we knew we wanted to figure out how to evaluate this because we want to say, okay, does it have a sum or not? So if it has one, converges. If not, it diverges. All right, so for the next part, the sum of an infinite geometric series is this formula right here. And of course, for this, that's only for when your common ratio, the absolute value, is less than 1. That's when it converges to a sum. So a sub 1 is the first term and R is the common ratio. So if we look at these two questions right here, it says find the sum of the infinite geometric series. So if I want to find the sum, I need to find those values that we just talked about. So first I want to look at my common ratio. So my common ratio is 1/2 divided by 1, so 1/2. The absolute value of this case of R is less than 1. Therefore, we know it converges and has a sum. So to find the sum, I'm going to use that formula. So the sum is equal to the first term, which is 1, over 1 minus my common ratio, which is 1/2. So if I were to evaluate this, the sum that we would be approaching would be equal to 2. I could also write this using that summation notation. So the sum of the first term, and of course we would be going on to infinity. And then if I want to write that, then I would need to know what the explicit form of this equation is here. So for the explicit form of this equation, we know it's the first term times the common ratio to the n minus 1 power. And let's go ahead and take a look at what the calculator looks like for that. Oops. Okay, so I forgot we can't do this in our calculator because we don't have the infinity symbol. So this would just be the summation notation way of writing it. And of course, that would just be equal to 2. So over here, to use the formula again, we have our R value is equal to, so -3/2 divided by 3, which is equal to -3/2. Remember, this is times 1/3. So this would be -1/2. So that means the absolute value of R is less than 1, which means it converges. So it has a sum. So the sum is equal to, and again, it would be the same thing for this. You take your first term, which is 3, over 1 minus negative 1/2. So 1 minus negative 1/2, remember that becomes plus, so this would end up also being equal to 2. All right, so let's actually go to a new sheet. So for the next example, it says a ball is dropped from a height of 10 feet. It hits the floor and bounces to height of 7.5 feet. It continues to bounce up and down. On each bounce, it rises to 3/4 of the height of the previous bounce. How far has it traveled, both up and down, when it hits the floor for the ninth time? So there's a couple different ways to do this. Why don't you take a minute to pause the video and see if you can do it on your own first, and then we'll take a look at it together. So the first thing I like to do is kind of draw a picture. So we have a ball, and we're dropping it from a height of 10 feet. And each time it hits the floor and bounces to a height of 3/4 of the previous bounce. So of course, in this case, the first time it tells you it's 7.5 for the first one. So that's one bounce, and that's 7.5 feet. And so then we have, it's going to keep on going, and it's asking for when it hits the floor for the ninth time. So this would be the first time it hits the floor, and the second time it hits the floor, so that would be one bounce. So then we have, so 1, 2, 3, 4, 5, 6, 7, 8, 9. And this would, so this whole thing right here is one bounce. This would be 2, 3, 4, 5, 6, 7, 8. So 8 total bounces, or you could say that you can look at the number of times it goes down versus up. So a couple different ways. So let's look at this in terms of the total number of bounces first. In this case, the total number of bounces n would be equal to 8. Your first term would be your first bounce. So remember that this height of 7.5 is the height of the bounce, but not the distance that it's traveled, because we want to figure out how far have we traveled both up and down when it hits the floor for the ninth time. So the whole distance that we are looking at is the distance here, 7.5, and this is also 7.5. So 7.5 plus 7.5 is 15. And then we have our common ratio, which we know is 3/4 because that's what it told us in the problem, rising to height of 3/4. And so for this, if I want to find the sum, we're going to go ahead and use that new formula. So the sum of the 8 bounces would be equal to the first term, which is 15, times 1 minus 3/4 to the power of 8 divided by 1 minus 3/4. And if I plug this into my calculator, I get the total, but the total, hold on, being equal to, let's go ahead and plug that in. So 15 times 1 minus 3/4, so 0.75 to the power of 8 divided by 1 minus 3/4. Oops, I didn't realize that numerator was not in parentheses. So I need to add another parenthesis there, because otherwise we're doing 15 times all of that. Okay, I didn't notice last time I had the plus 1 plus 0.75 instead of minus. So if I go ahead and hit enter now, I get 53.9932251. So if we go back to our equation, remember that this was looking at the sum in terms of the number of bounces. But if we look at this first portion, this is not included in the bounces. So this is not the incorrect total altogether. We actually have to add 10 to that. So if I go back to my calculator and I hit plus 10, I get 63.9932251. So for this, we're going to round using 4 decimal places. So for this, we're going to write that the answer is 63.5 .9932 feet. Another way you could have done this is by looking at using the summation notation, so the sum of the first bounce to the 8th bounce, and then finding the explicit formula, so 15 times 3/4 to the n minus 1, and of course we still have to add the 10 to that, so you can do it in front or back. I'm going to put it in the front so we don't get it confused with being here. And then I could also plug that into my calculator and I would get the same thing, 63.9932 feet. Either way is fine. So that's not the only way we can figure out what the total distance traveled is. Another way is to look at the total of the distance down plus the distance up. So total down plus total up. So for down, if we look, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So that means your, in this case, n would be equal to 9. Your first term would be equal to 10 because that would be the first drop. And r would be equal to 3/4. And then for this, we get the sum of n equals 1 to 9, and then you would need your explicit formula. So that would be the first term, which is 10, times the common ratio, which is 3/4, to the n minus 1. And then you would need to add that to the total distances going up. So that would be 1, 2, 3, 4, 5, 6, 7, 8. So n is equal to 8. A sub 1 would be equal to, so remember your a sub 1 is, this is your first term right here. So in this case, 7.5 feet. R is still equal to 3/4. So the sum of n equals 1 to 8 times 7.5 times 3/4 to the n minus 1. And you would just add those together. And if you did that, you would also get equals to 63.9932 feet. Of course, that's not the only way you could do this problem. There are a couple different other ways, but these are just two different ways that you could approach this problem. So let's go ahead and look at the last example, 6. Example 6 says evaluate each infinite series that has a sum. So for this, remember, we cannot plug these into our calculator, so we're going to have to look at our equation to kind of help us. So remember that when you're using summation notation, we know we're using the explicit form. So this says we want to find the sum of the term 1 to infinity, so we want to find the sum of all the terms. So for this, I can see that this has an exponent of n minus 1. So again, we know it's our first term. If it's not written, then of course your first term is just 1, and this would be the common ratio. So the common ratio is equal to 1/5. So that means that the absolute value of r is less than 1, so it converges and it has a sum. So the sum is equal to 1 over 1 minus 1/5, which is equal to 5/4. Over here, we do the same thing. So we want the sum of all the terms. So in this case, we have r is equal to this value here, which is 5. So the absolute value of r in this case is greater than or equal to 1, which means that this diverges. Which has no sum. And that's it.